Hi everyone, my name is Uncle Prince. So what we have today, this dimension. So in dimension helps to describe the nature of a physical quantities in terms of the basic quantities. We have the mass, the length, and the time. So we can also talk about the importance of dimension. So dimension helps us to convert an equation and a unit and check whether an equation is correct and even to drive some equations. That is the work of dimension. So now what do we have now? We are asked to find the dimension for what? Area, weight, velocity, acceleration, force, density, and what? And pressure. So let's go with area. That is the first one. So area now is what? Length times length. Are we following now? So length times, in our normal mathematics is what should be what? Length times width. But this is physics. So this length, this width now turns to what? Length. So we have that is in dimension. We have length times length, which is what? L what? Square. That is the dimension for what? Area. So we have weight. Weight we know is length times width times length times width times what? Grade, anyone. So we have in dimension should be what? Length times length times length, which is what? L cube. L raised to power 3. Are we following now? So the next one is what? Is velocity. Velocity is what? Displacement over what? Or time or distance over time. Are we following now? So in dimension, displacement is what? And time, this is what? Is t. Notice now, mass is what? Length is what? And time is what? T, all in capital letter. So we can also write this like this. T raised to power what? Minus 1. According to the laws of indices. Acceleration is what? Velocity over time. So no need of finding, no need of going on looking for what? Velocity. Since we have our velocity to be what? T raised to power what? Minus 1 over what? Over t. This t, that is the time. So sorry, minus 1. So what do we have now? It will not be what? It can yes, we now have what? It will not be what? C raised to power what? Minus what? Minus 2, because of this t and what? And this t. Are we following now? So according to the laws of indices, or you can write it this way, that L over what? This t square, that is t for this one and what? T for this one in velocity, that is what? T2. So what do you have here? Force now is what? Mass times acceleration, and acceleration, have acceleration to be what? Acceleration is L t raised to power minus 2. So no need of looking for acceleration. Now what? Mass is what? Is m. Then our acceleration L t raised to power minus 2. So here now we have density. Density is what? Mass over volume. So and mass is what? Is m over our volume is what? Is L cube. So or you can put it this way, L raised to power what? Minus 3, according to the laws of what? Of indices. So pressure now is what? Force over what? Over area. Force is what? Where is force? Okay, force is nothing. Okay, force is what? MLT minus 2. So we have MLT minus what? 2 over what? Our area is what? Our area is L raised to power 2. Sorry, our area is what? L raised to power 2. So what do we have now? We now have L, that is 1 minus what? Minus 2, and what? T raised to power what? Minus 2, which is equals to 1 minus, this minus is because this is dividing. Are we following? This L2 is dividing. So if you want to write it now, it will not be L minus what? 2, because it is dividing. Are we following now? So this ML, that is 1, M raised to power 1, M raised to power 1 is the same thing as L. Then minus 2, which is same thing as what? L minus what? 1. So what do we have now? We have ML minus 1, then T minus 2. This is the dimension for pressure. Thank you so much, and God bless.